All right, so today we're talking about multiplying polynomials. So when we're multiplying polynomials, we got to know about, we got a couple of terms that we have to understand. So I put 4 terms over here, and you notice that each term is separated by addition or subtraction sign. So what I'm going to do is this. I'm going to say it this way. So right here, I'm going to underline that's a monomial. This is a monomial. This is a monomial, and this is a monomial. So everything marked in red is a monomial. Okay? Now, if it's a binomial means 2 terms, so right here or right here would be a binomial. And if it's a trinomial, that means it's 3 terms. So that'd be a trinomial. All of these, no matter if it's 1 term, 2 term, 3 terms, or 4 terms, 5 terms, 6 terms, 100 terms, the rest of it is called a polynomial. Okay? So everything else is under the umbrella of a polynomial. And we can think of it that way. All right. So now we're going to talk about multiplying. Well, if we multiply monomials, it's going to be bring in the same rules as we had with exponents. So if we had, let's say, for example, a negative 2x squared times a 3x, right? We would multiply the numbers by themselves, okay, and get you a negative 6, and then we will multiply the x's together, okay? X squared times x, we will add the exponents, so we get x to the 3rd. And that would be my answer. So monomials are pretty easy. We've been doing it with exponents. So those are all multiplying monomials, okay? Now, we could have a monomial times a binomial. So let's say I have a 4x times a 5x plus 7. Actually, let's use this right there. Okay, so we could think of this as, keep on being indecisive with my markers, times a 5x. And this is considered called distributing, plus 4x times 7. So yes, we are calling this would be called distributing. Okay. So with that being said, then my answer is going to be 20x squared plus 28x. Because what I would do is multiply the numbers together. X times x would give me x squared. Multiply the numbers together. 4 times 7 is 28. And then have the x left. So that would be my answer. Okay. Well, what if I had, let's say, a binomial times a trinomial? Okay. Now, one of the things I want to bring up to you guys before we keep on going. So a monomial means that it is 1 term. Let's use that right there, right? It means that there's 1 term. A binomial means it's 2 terms. And 1 times 2 would give you, I have 2 terms left. Monomial times monomial gives me a monomial. 1 times 1 is equal to 1, okay? So that's not too bad. So my question is, if I do a binomial times a trinomial, how many terms should I get? That's right, 6, okay? So let's take a look what that looks like. So if I have a binomial times a trinomial, So I know that this should give me 6 terms. Okay, so let's see. So what we would do with this is called a double distribute. Okay, meaning I'm going to take the 2x, distribute it, and then I'm going to take the -8 and distribute that. And that's what we want to do. So if I was to write it out, and I would recommend if you're not good at seeing those lines or drawing those lines or be organized with drawing those lines, here's what I say. I would tell you to write down the first one, and you're going to multiply through with x cubed minus x minus 3. Then take that -8 and distribute it to x cubed minus x minus 3. This way is a lot easier to see of what you're doing. So then I'm going to have a 2x to the 4th minus 2x squared minus a 6x minus an 8x cubed plus an 8x plus a 24. Okay. Actually, you know what? Let's go even better with this. Let me do this. So we're going to do this, which is going to give me a 2x to the 4th. This times this is going to give me a negative 2x squared. And that's going to give me a negative 6x. Okay. I'm going to use the same colors again. That's going to give me a negative 8x cubed. That's going to give me a plus 8x. And this is going to give me a plus 24. All right. So, do I have 6 terms? I do. 1, 2, 3, 4, 5, 6. I do have 6 terms. Awesome. So that's always a good check to make sure that you have enough terms. Then I'm going to look at, hey, do I have any like terms? I do. I have a like term right there. Now, what I want to also do is that when I write this answer, I want the powers to go from largest to smallest. So yes, the 2x to the 4th is the first one. Then minus 8x cubed. Then minus 2x squared. And the 2 that I have underlined is just x, but they're like terms, so I can add them. So I have a plus 2x, then plus 24. Okay, yes, it went from 6 terms to 5 terms. That's okay, as long as that intermediate step, I do have all 6 terms. That's what really matters. Okay, there we go. So that's a binomial times a trinomial. All right, so what if I have a binomial times a binomial? So if I had, let's say, a v minus 4 times a 2v plus 6, okay? So you would still do double distribute, okay? And then there's also people that talk about FOIL, right? So FOIL is first, so FOIL, let me do it, that's fine. FOIL, actually let's write it this way. FOIL stands for first, which is the first term in each group or binomial, okay? Outer, that means the outer pieces. Inner, that means the inner pieces. And then, oops, last means the last term in each group. You may do that if you want to. I'm not going to tell you no. However, people do mess it up because they start drawing lines and lines get messed up. Now, I'm going to do double distribute. Okay, so before I go into that term, let me show you what first would give you, right? So first would be the first one in each group. So that would be v times 2v, right? All right, and then we said the outer, which is the outer 2, which would be v times 6. Then inner, I said was the inner 2, which would give you negative 4 times 2v. And then we have last, which is the last term in each group. So that'd be negative 4 times the 6. All right, so that is what the values I would have if I was doing FOIL, but I got finished it obviously. But I'm gonna show you what double distributing would look like, right? Which is exactly what we did up here. So I would write the first term, v, and multiply it through with the 2v plus 6. Then take the negative 4 and multiply through with the 2v plus 6. Okay? And if I was to distribute this, this would give me a 2v squared. This would give me a plus 6v. This would give me a negative 8v. And this would give me a negative 24. Okay? Now, let's go back here. Let's take a look. This would give me a 2v squared. This would give me a 6v. This would give me a negative 8v. And this would give me a negative 24. Look at that. You are essentially doing the same thing. This way, it might be easier to organize, right? Where this, if you start drawing lines, you might draw the wrong line. So you just gotta be careful with that, okay? I like the double distributing because it's more organized, and the double distributing will look very familiar when we're going backwards. So everything in this chapter, well, everything in math, we gotta know how to do it going forward and also going backwards. In other words, let me finish this problem here. Now, I do have like terms. And remember what I said, binomial times a binomial, I should get 4 terms, right? And I do have 4 terms right here. So that is clear. So I'm going to have a 2v squared minus 2v minus 24, okay? And that would be my answer. So in terms of going forward and backwards. So what I'm trying to say is this. Oops. Okay. What I'm trying to say is this. Yes, we are starting at this point and we're going to finish at this point. That's called multiplying polynomials. Okay? So this is what where we're going towards. So that's going forwards. However, later in this chapter, we are then going to start here and ending with binomials, okay? So that is also important for us. So we're gonna have to be able to do going in both directions. Now, if I was to add these 4 together, which again, I have common denominators like terms right there, so I can add those together, which give me a negative 2v, okay? So I would still get the same answer. Got it? All right, next. So let's try another example. Ooh, this one I like a lot. All right, so let's try this one. This one is going to be a 9x plus 2 times a 9x minus 2, okay? There is a special name for this. The special name for this is called the conjugate, okay? The conjugate, if you notice, has the same terms, but one is subtraction, one is addition, Okay, so they're both 9x and 9x, 2 and 2. One's just addition and one is subtraction. Okay, well, let's see what happens. Oh, excuse me. Let's see what happens when we double distribute this. Okay, so I did do this. Let me see. Let's do this the same way. There we go, and change that to red. Awesome. So I'm going to take the 9x and multiply it to the 9x minus 2. And then I'm going to take the plus 2 and multiply it to the 9x minus 2. Okay? So what do I get? This is going to give me 81x squared. Then this is going to give me a minus 18x. This is going to give me a plus 18x. And this is going to give me a minus 4. Okay? I do have like terms here. And look at those like terms. One's positive, one's negative. Awesome. So what's my answer? 81x squared minus 4. Okay? So if you notice, over here when I had a binomial times binomial, it got to 4 terms, but then it collapses down to 3 terms, a trinomial, right? But with a conjugate, look at what happens. I still end up with 4 terms. I'm sorry, I still get the 4 terms in the intermediate step here. But what happens to my outer and inner? It goes away. So I'm left with first and the last. Okay? So over here, if you notice, it is the negative 2v came from my outer and inner, right? And that this piece here came from my first, okay? And this negative 24 came from my last, all right? So I want you guys to understand that. So same thing here. That's the reason why I say my oi goes away, okay? Left with my first and my last, but that would be my answer there. Now notice this also. Notice how I am multiplying 9 times 9, x times x. 81x squared is a perfect square because 9 times 9 equals 81, x times x equals x squared. Similarly with the 2 and the 2. 2 times 2 is 4, which makes 4 a perfect square, okay? Just things to point out. That's it. I want you guys to just remember that, okay? Because that will come back up. And then you're going to have a question about this. And people typically make a mistake with this. 5x minus y squared, okay? So what people tend to do is that they mistake this for the same as this rule right here. Remember the a times b raised to the nth power, right? Or let's even use squared. Let's just use a square here. So this would be a squared times b squared. So people typically mistake these two properties here. However, remember that this is a multiplication while this is a subtraction. It does work for multiplication, but it does not work for subtraction, okay, or addition. Only for multiplying and divide. Okay, I want you guys to understand this. So I'm going to put down right here, not the same. Okay, so with this one, what we have to do is the exponent tells me to write the parentheses twice. So I'm going to write the parentheses twice. Then it's a binomial times a binomial, so I have to double distribute. So what I'll get is 25x squared minus 5xy minus 5xy plus y squared. I have like terms, so I'm going to get 25x squared minus 10xy plus y squared. And that would be my answer. Right there. All right. Now, I know that you guys are going to have this question here. Oops. And that is, when I multiply these two, how did I get negative 5xy? Well, I have a negative 5 times y times x. That is the same as negative 5xy, okay? Because if I did 1 times 2 times 3, is that the same as 2 times 3 times 1, or 3 times 2 times 1, or 2 times 1 times 3? Those are all the same. That is called the commutative property, okay? So those are all the same. So that's the reason why you got the negative 5xy. Okie doke. And like I said, typically we write the larger power first down to no power. Same thing here. Same thing here. And over here, yes, the x and y don't have powers. They're both a power of 1. Now we do want it to be alphabetical as well. Okay, so when you're ever wondering, I don't know which one to write first, or in terms of the variables, always write it in alphabetical order. Okay, all right, and we will see this as well. So everything that you see going forward, you will see going backwards as well. All right, so the last one I'm going to go over, because this typically comes up as well, is what if I have x minus 9 times x plus 9 times x squared plus 81, right? Oh no, oh no, oh no. I have 2 terms times 2 terms times 2 terms. What do I do? Well, if I was to give you, for example, 238 times 27 times 52, right? If you didn't have a calculator, you would multiply these two first and then multiply by the 52, right? We are going to do exactly the same thing. We're going to multiply these two first, and then whatever the result is, then multiply to that, okay? So let's go ahead and do that. So we're going to only take care of just this piece first right here, okay? So, and look at that. That's a special. It's a conjugate. So I'm going to get x squared plus 9x minus 9x minus 81. So I got x squared minus 81. Now I can bring that last piece down of x squared plus 81. Okay, so bring this down to there. Okay, so again, I dealt with the first two first, now I'm bringing in the third one. So I double distribute again, oops. So I'm going to have x squared times the x squared plus 81. I got a feeling we're going to have a really big number. Minus 81 times x squared plus 81. Okie doke. So, what do I have? I'm going to have x to the 4th plus 81x squared minus 81x squared minus 6,561. That's what 81 times 81 would be. But again, this is a special one still, right? This is still a conjugate, right? Same terms, x squared, 81, 81. Just one is addition, one subtraction. So, but look at this. I have like terms, but they go away. So my final answer is x to the 4th minus 6,561. Okay, So notice so far, we've done 3 things of conjugates. This was a conjugate. What did we get? 81x squared minus 4. We did a conjugate right here. And what was the result? X squared minus 81. Then we did another conjugate right here. What was the result? X to the 4th minus 6561. Okay? So just put that in mind as we're going on. All right? So this is multiplying polynomials. If you have any questions,